All right, sports stats students. So with me being out today, this is how you're going to receive your lesson. We're going to go ahead and get things started today. So here's what you guys are going to need, and we can pause if we need to make sure that we have these things out, but have out notes, have out a laptop as well, have your email open, and have your Staplet open as well. The email open because by now you should have already received an email from me for data that we're going to be doing some comparisons with. So if we want to go ahead and pause the video, just make sure everybody has what they need so that we can start the lesson out. Okay, so now that we have our emails open, you should have an email from me. I'm going to go ahead and pull this up one second. All right, so this is the email you should have got from me. It just says preview the attached. All you need to do is click the Excel spreadsheet here, and inside of it you will see this is the week one. This is the NFL this past Sunday, Monday Night Football, last Thursday night. These are the the leaders for passing yards. Okay, so let's see, where's the yards? Right here. This column L is the yards. So these are the leaders by yards. And so we're going to be using that data to help us out and to learn with today. So we've got our notes out. Here's what we're going to do. In our notes, this is what I need you to maybe start a new page. That would be fine. But this is what you're going to write. Typically throughout these slides, we're going to be writing the things that are highlighted yellow, but that doesn't look too good here. So you're just going to write this highlighted part right there. If we want to pause the video briefly, just to make sure everybody's got it. So at the top of your screen, top of your notes, you're going to be writing bivariate data, scatterplots, and correlation. Okay, scatterplots and correlation. So go ahead and write that down at the top. If we need to pause it briefly, let's do that. Okay, let's show you sort of an end goal of what you're going to be creating as you are thinking about as we learn these topics. Okay, so this is a product from last year that a student made comparing NBA player stats, comparing field goals. Now, a field goal in basketball is just shooting it on the court. It could be a 2-pointer or a 3-pointer. It doesn't matter. And we're trying to show a relationship that, as you can see on the y-axis here, let me zoom in on this graph. On the y-axis, you have points and field goals taken. I guess this is per game. And obviously, there's a very strong relationship between that. I think everybody can make sense of this. As we increase the amount of field goals that we take, we're going to get more points. So I think this is field goals actually made is what this is. So they make more field goals. The points are going to go up. That's obvious. Now you have a few varying outliers here, but overall it makes sense. Now there's a lot of extra stuff around this. For instance, we're going to be learning about how to describe this distribution a little bit more efficiently. That's what this highlighted part is here. We're going to learn how to make a linear equation out of this. So there's a line here that's going through the graph. That's called the line of best fit. You've probably dealt with that at some point in your math schooling. Then we have these interpretations down here, reading the data, reading beyond the data. We've done plenty of reading beyond the data in this class. Let me move my camera over here. Plenty of reading beyond the data in here. So you can see that students' interpretation there. Now, this example will be put on Teams because you'll be given this assignment, and it's probably going to get started with it today. We'll see how far we get. I think I told you guys that this would be like a 30-ish minute lesson. So we might only get to these couple of things right here, but we'll see what we can get to today. Lastly, you have something called interpolation and extrapolation. Okay, interpolation and extrapolation. We'll, of course, talk about that in the coming days. Okay, so this is sort of the end goal. This is the end product of what you guys are going to have to do on your own. There's definitely going to be test questions about this on our test, which we are taking our test after we finish really the lesson and these concepts that are in this slide. Our test will be following that shortly. Okay. All right. So let's go ahead and get things started. Let me zoom out. Okay. So let's first talk about something called, let's write these two definitions here. You have an explanatory variable, a response variable, and an explanatory variable. Okay. So you can start writing these as I'm talking, but once I'm done talking, I want to ask to pause. Whoever's showing this video, hit spacebar just to make sure everybody has time to write it. So first we have a response variable that measures an outcome of a study. And then an explanatory variable may help explain or influence changes in the response variable. Okay. May influence that response. Okay. So we usually think about the response variable as the y variable. Actually, we always think of it as the y variable. And then you have the x variable. So when we look here, this student had to make the choice about which one was the explanatory variable and which one was the response variable. So as we look at this, you can be thinking, oh, field goals explain, like how many field goals I make in a basketball game. This is NBA players, by the way. Directly influences the response, which is points. I mean, that just makes absolute sense, right? Sometimes these don't really relate too well. We're going to look at different relationships that exist within this. Okay. So here, make sure you're writing this. You can pause it really quick if we need to. But let's go ahead and look at this. It says, in many studies, the goal is to show that changes in one or more explanatory variables actually cause changes in response. You don't have to write this in response to variable. However, other explanatory response relationships don't involve direct causation. So we've talked about this idea of cause and effect. I would say that this example here, like making the field goals, is causing the points because this is a very strong relationship here. You can see the student had pointed out that it is strong. Indeed, it is strong. Okay. So that's something that you're going to be thinking about. We're going to be talking about, and especially this R value here. That's something that we're going to be looking at. Okay. So let's go ahead and move on to the next definition. So let's talk about what a scatter plot is. A scatter plot shows the relationship between two quantitative variables. Every graph that we've been doing has been one quantitative variable. Okay. Now we're taking two of them and comparing. This is very similar to the two-way tables that we did, except that was for categorical. Okay. So this is going to be quantitative variables. There's two of them. Okay. Measured on the same individuals. All right. Measured on the same individuals. Each individual in the data appears as a point on the graph. So if we need to pause so that everybody can write, remember, you're just writing the yellow. That's all you have to do. Okay. That's all you have to do. So let's pause and make sure everybody has that. Okay. So how do we make a scatter plot? Well, let's go ahead and make a section in our notes right here. How to make a scatter plot. That looks terrible when the white text is yellow. How to make a scatter plot. Step 1. Okay. Decide which variable should go on each axis. That's important. Okay. Here we would not want points to explain field goals. Okay. We would not want points to explain the field goals because it doesn't make any sense. The number of field goals a player makes explains, okay, what happens. Okay. It says, remember, the explanatory variable goes on the x-axis. You don't have to write that unless you want to. Number 2, label and scale your axes. Well, you're not going to be drawing these by hand. We're going to be using Scatterplot to do this. So this is not going to be too big of a deal. And then plotting the individual values. Again, Scatterplot is going to come and save the day for us on that one. Okay. So pause this if we need to. And we're going to go ahead and start setting up in Scatterplot. You have Scatterplot open, so just get that ready. But let's pause this if we need to. Okay, so let's get Scatterplot open. Okay, so we have all of these lists here. You can see that my ones that I've been using, at least here on my home computer, have been the one quantitative variables. And that's what we've been doing for all of these different plots, the stem and leaf, the box and whisker, the histograms, and the dot plots. We've been doing all of those, but now it's time to get into the two quantitative variables. So let's open that up. And now let's look at our list here of all of our different variables. We know that we're interested in yards. Okay, I don't know why this looks like this, but I feel like yards if we want to compare yards to something else, let's compare yards to touchdowns. Maybe that's interesting to do. So step one, which one would explain the other? Does touchdowns explain the yards, or would more yards explain more touchdowns? Well, what I just said makes more sense in my opinion. Okay. So in our notes, let's go back. Let's go back to the PowerPoint here. 1 second. I just sort of have my little sheet here. I'm going to play around with this. So in your notes, let's do example with our scatter plot. We're going to do yards versus touchdowns. This is just week 1, right? So let's go ahead and write out in our notes. So please write this as I'm typing it. Okay, I'm going to try to make that larger so you can see. So the explanatory variable would be the yards. We think that yards would explain touchdowns, perhaps. Response variable would be touchdowns. Okay, oops, spelling. There we go. I got Grammarly to save me. Okay, so let's go ahead and just see how this works in Staplet. Okay, so we're going to go ahead and we're going to highlight this entire section here. Actually, we want yards. So let's copy that. We know how to do this. Copy that, and then let's go back to Staplet. Go back to Staplet here. We want yards to be our explanatory variable, and we're going to paste this in here. Now I'm going to get rid of this. We know how to do that. There's our yards. We've got our yards in there. Now let's go back and let's get the touchdowns. So that's column M. All right, and we're going to go back to Staplet. So we have TDs. Okay. All right. Let's see what we get. Will it be an extremely tight formation like these points are here? We've got every quarterback here. We're going to have a lot of dots. I don't know exactly how many we have. Looks like actually it's just 37 quarterbacks represented in this data. But what we're going to do is hit begin analysis. And look at this. We get a kind of a very strange looking dot plot right here. And it does not look, well, really what happens is we can't get half of a touchdown. You see that on the left side over here? Like we can't get 1.5 touchdowns. We get half a touchdown. So these values are kind of very lined up. Okay. They're in sort of rows in the Y variable. Okay. But we get this graph here. Now I'm not going to make you draw it or anything, but we just have an example in our notes of how to do this. So let's actually write down the steps. So in Staplet, okay, so that's what we're going to say. We want to go to, let's just make sure we have this right. So we want the 2 quantitative variables. So I'm going to put that in my notes here. So we're going to 2 quantitative variables. Okay. So that's the one that we're checking. We're going to determine and input data for the explanatory variable. Zoom out. There we go. And then 3, determine and input data for the response variable. I don't know why I want to capitalize these. Okay. And then you hit begin analysis. Okay. We are going to save, we're not literally saving this like to a file or anything, but we're just going to keep this one here. Okay. And what we're going to do is we're going to make another one. Okay. So let's go back to open in a new tab. You can see I have 2 tabs open. Open another tab and let's do another one. And this time let's see what yards would be compared to. So we're going to copy and paste our yards in here. I'm going to pause for a second, and you don't have to pause the video, but just make sure everybody gets theirs copied in. I'll give you like a couple seconds to get yours copied and pasted in there. I know I've got 3 monitors here, so I can sort of quickly go from one to the next. but obviously you have the 1. So get those yards pasted in. And now we have to determine, what variable do you think goes with yards? Well, maybe attempts. Attempts should explain yards. It feels like if I have more passing attempts, I should get more yards, right? So we're going to put the attempts. I think that makes sense. We're going to put attempts in here. So we're going to say passing attempts. Okay. We're going to paste that in there. We're going to get rid of that. So I'll give you a moment to get that copied in, and then let's hit begin analysis. Okay, cool. Yeah, this one looks more like what we imagine a scatter plot to be. So we have this one here. You can see it's very tight down here, and then it sort of starts blooming a little bit at the end. If we had to describe how it's doing, this one, we have these people down here that I guess they got in just briefly, 1 attempt, 2 attempts, and no yards at all. I don't know who these people are. Tyrod Taylor got in, it looks like, and Aaron Rodgers, bless his heart, he had a rough one, didn't he? 1 attempt, okay, and he got nothing on it. So that would be an ideal of like reading beyond the data, right? Like that's already giving an example. You could say Aaron Rodgers had 1 attempt and then got hurt and taken out, and Zach Wilson took over the rest of the game. How did Zach do? Let's see. Where's he at? Zach Wilson. Here he is, 27. He had 21 attempts. So that's Zach Wilson's production there. The Jets ended up winning that game. It was amazing. But this is a good looking scatter plot. I really like this one here quite a bit. Okay. I like that one quite a bit. Let's see, how are we doing? We're at 17 minutes in. Let's keep trucking. Okay. So to describe scatter plots, let's actually I want to change the way that this looks here. These are going to be the main ones that we use, but I'm going to add a new slide. In your notes, you know how we do sometimes. We'll do a little star, right? And say describing scatter plots. Now we remember, look at that spelling. We remember that we had to like describe these quantitative distributions, right? Where we had the shape, right? The center, spread, and then of course describing outliers. Those are the main things that we describe. Okay. So for a scatter plot, you start with direction. Okay, so that would be one of them. Give yourself some space. I would say put a line of space between all of these, just in case I want to write some more stuff in here. So you have direction, you have form. Okay, form. Then you have, what is this next one? You have the strength. And then you have outliers. Okay. You have outliers. So these are the 4 ways. So make sure we're writing all these down. Okay. Just to show you an example, you can check this out. Look, this is exactly what my student last year had to do. Okay. Direction, form, strength, and outliers. Okay. So we're going to talk about each one of these. I guess our lesson today will probably just be on these, because this will probably take up the next 12 minutes to go through. And I want to make sure you guys have time to get some work done on the assignment. Okay. All right, let's go ahead and talk about direction. Okay. So direction can be positive, negative, or no direction. Okay, no direction. Let's go ahead and go down below your outliers, and we're going to say describing direction. Okay, and we're going to put some notes underneath this in your notes. Okay, so let's go ahead and go to the next slide. So we've got two sort of wordy definitions here, and I apologize. It's going to be quite a bit of writing, So I'll definitely pause it and let everybody get what they need written. Positive association is more of a visual, and so is negative association. Like, you know it when you see it. So this definition is pretty intense. But when above average values of one variable tend to accompany above average values of the other, and then when below average values tend to occur together. Now, that may not make any sense right now, but we'll write it down and then talk through both of these ideas. So anyway, negative association is when above average values of one tend to accompany below average values of the other. So let's pause the video. So I'm going to hit space bar just to pause it. And let's get this written. I'll make that larger there for you. Let's pause and get this written. Okay, so the visual for this, when we talk about the association, just the direction, you have positive and you have negative graphs. If we look at our Scatterplot graphs, I think we all realize that if I do above average passing attempts, like if I have a lot of passing attempts up in the 50s, we're seeing it begins to raise up the yards, right? That's what we're talking about with a positive association. You probably think about linear functions that you've learned about in your iMath classes. That's the idea here. It's going upward. Okay, now we'll talk about shape or form in a second, but with the students right here, yeah, we're absolutely seeing as field goals increase, we're getting points that are increasing, and it's pretty steady too. Like, it's just a very strong relationship between those, and so that's the idea with these two things here. Now, sometimes you get graphs that just don't have any association at all, no direction to them. That's why we put in here, no direction is the other option, which you just can't make out a shape. It's just not possible. Okay. I would say if we went to our other one, here's the yards and touchdowns, we're definitely seeing a positive trend, right? As we increase the yards, we're seeing more touchdowns happen. And so this is also a positive. I'm trying to think of what would be a negative association. What would be a negative association between these values? A lot of these, as one increases, the other is decreasing. Actually, I thought of one. Let's do this one here. Open up a new tab and do Scatterplot. Open up a new Scatterplot. We're going to do a brand new one here. I think one that makes sense is if we have quarterback rating, right? And those that are into football, we know that this is sort of a quarterback's overall success rate. And then we compare that to interceptions thrown, right? Obviously, if you're throwing a lot of interceptions, your QBR should be much lower. Okay. Now we can already see Jordan Love. He didn't do too bad. He has 73 QBR. He had three interceptions, but normally we're going to see higher QB ratings. Maybe this doesn't make sense. We're going to see. Go ahead and put QBR. So let me show that. Let's see, QBR is right here. It's column Y. Let's copy that and paste it into Scatterplot. Mine is being a little weird here. Okay, got mine in. And then we're going to do interceptions. Okay, we're going to do interceptions. Paste that. Now this one's going to look a lot like the touchdowns thrown. So don't be too surprised when this one also looks kind of funny. But we're definitely, like, this one is really weird. We're definitely seeing a downward trend. I might even change interception thrown. Let's change it to percent. I'm sorry. Let's edit these inputs. And let's change this. Let's get rid of this. Control A and delete. We know how to do that. Do interception percentage. I think that might look a little bit better. Okay. Do interception percentage. That's column P. That looks much better. We can see an overall trend, at least here, the percentage thrown. Who has the highest percent? Oh, our boy Ryan Tannehill. He had a rough game and threw 8.8%. So he wins for throwing interceptions this week. Sorry, Titans fans. It's just that's pretty brutal. But we can see a negative trend there. Now these bottom values are kind of interesting. I think if we got rid of people who, like, this guy has no QBR at all, and he didn't throw any interceptions. So this bottom row, I guess if you have a high QBR, 0 interceptions thrown. But we can see, man, a lot of people threw interceptions. That's a lot of interceptions, actually, for a lot of these quarterbacks. But this is an example of a negative association. As the QBR is going up, we see that interceptions thrown percentage is going down. So that's a good example of that. Okay. So that's what the student had to decide when they made this graph here. The direction, either positive or negative, is really what you want to say. Okay. Let's talk about the forms. For form, you are going to have linear or non-linear. Okay. Linear or non-linear. Now, I'm just going to go ahead and be honest with you. This one does not look linear when you consider all the dots. This one looks more linear to me. Okay. Well, you can just tell by the overall trend of the data, how close the points are. This one here does not look that linear to me. Now, it's a positive association, but it doesn't look quite so linear. Not yet, at least. Maybe as the season continues and more touchdowns are thrown, we'll get a better looking graph if we wanted to come back to this and do something with this. But right now, it doesn't really have much form. When we look at this, where they had, this is NBA player stats. We have tons of data here. And this is just a very, very linear relationship. You can just see how close the dots are in a line. And so there's not much else to write about this. That's just sort of what we have to decide here. Okay? That's what we have to decide. Okay, now we need to talk about strength. Okay? So strength, you have a few ways that you can describe strength. So to describe strength, we are going to use the correlation coefficient R to determine strength. Okay? Use correlation coefficient R to determine strength. Okay, so that's in this section up here. Now we're going to make a, down below where you said describing shape, we are going to talk about the I'm going to talk about, let's see, I'm going to copy this here, measuring linear association right here. So this is what you're going to write in your next section. And here we're going to put strength. Pause the video if we need people to catch up with their writing, because you had to write this here and you had to, now you're writing this in the below in your notes. Okay. 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 So, we have this coefficient R. Okay. This R value in the student's work, you can see that they included it. You see that? This R value. And we could already say, hey, this looks like a very strong linear relationship. Okay. Well, how do we do this in Staplet? So in Staplet, we're going to, let's go to this one. Let's go to our passing attempts and yards. Let's do that. And then you're going to go down here and hit calculate correlation, and we get our correlation. Okay. So let's actually put that in Staplet. So in Staplet, after inputting data and beginning analysis, click, what does that button say? Calculate correlation. So that's what you want to click on there. And so that's pretty easy. It's very easy for you guys to get your correlation value. Okay. So let's write out the R values of our examples. So we have, let's do yards versus attempts. We have What were the other ones? We had yards versus touchdowns. We had QBR versus interception percent. So we're going to put the R values for each of these. Anytime you're talking about R, we're going to say R equals. So you can go ahead and write that to the sides of these. And go ahead and let's fill these in. Make sure that you were able to find this calculation. We can just I can copy. You guys just have to write it. So this is our passing attempts compared to yards. And I think I want to actually rearrange these. I'm going to move this here and this. I'm going to reverse those. Okay. So there is the R value for that. Now, what does that mean? Is that good? Is that bad? Well, we'll find out in a second once we get all these written down. So the next one is yards versus touchdowns. This is the first one we did. So let's do correlation. Look at that. So 0.62. So different, right? Not the same value. So yards and touchdowns, 0.629. Now let's do QBR versus interception percent. So let's calculate that. Okay, look at that. So we have a variety of situations with these R values happening. Okay, we have a wide variety of situations happening. Okay, sorry, I just moved my OBS to the left because we're about to write a bunch of stuff on the R values. Okay, so down here, we're going to have some space, okay, and we're going to write correlation. We're going to put a little definition down here. So I'm going to go to this PowerPoint here. We're not going to write that bottom point just yet, okay, but let's go ahead and write this first value here. Actually, you know what? I'm going to edit this real quick. Hold on. Okay, so hold on. We got it. All right. So first up, correlation R measures the direction and strength of the linear relationship between two quantitative variables. So that's important, direction and strength of the linear relationship. So let's go ahead and start writing that down. Give you a few moments to get that down. Obviously, for some of you who are slow writers, that's fine. We'll pause the video, make sure everybody gets caught up as we go through this, okay? Normally, I'd be in the classroom writing all this down with you, okay? Important facts about R. First off, R is always between -1 and 1. It never will go beyond that, okay? Next, if R is greater than 0, that's a positive association. We see that with the the yards and attempts, the yards and touchdowns. Like, we're seeing a positive association. Those values are greater than 0, and we visually saw that too. Negative. So if R is less than 0, it indicates a negative association. So we see that the negative, like with the QBR and interceptions, it was a negative. It went downward. It was negative. So that's why the R value is negative 0.16, because it's negative. Values of R near 0 indicate a very weak relationship. Well, which one of ours was closer to 0? Well, that QBR and interception one was. That's really because of that bottom row. We have just such a variety of attempts and QBR rating, QBR rating and interceptions. I know there's a lot happening as far as you having to write. Again, I will pause it and you'll be able to catch up, okay? But here's the fifth bullet point. The strength of the linear relationship increases as R moves away from 0 towards -1 or 1. Okay. Now notice here with this point, moderate. So we say that it's moderately strong if it's between 0.4 and 0.6. Okay. We'll break that down a little bit more. You can, like, very weak, moderate strength, strong, or very strong. Okay. So those are some differentiations of what you could say the strength is. Okay. I think that's the last bullet point here. The extreme values of -1 and 1 occur only in the case of a perfect linear relationship. When we're dealing with sports data, this isn't going to happen. Like, we're not going to get -1 or 1 to ever occur. It's just not going to happen. Okay. So let's hit the space bar. Let's make sure that we've got all of this written, and everybody gets caught up. All right. So you've had time to write all this. I know it's a lot. I thank you for bearing with me on this lesson. I know this is not typically how we do things. Okay. I do want to go ahead and share this scatter plot with you guys. This is showing some examples of the strength that we're seeing for different scatter plots. So just observe these for a second as I'm talking. Look at the correlation values. You can see on this top left one here, there's no association at all. It's 0. The strength is very, very is just not there. We don't see a direction. We don't see a trend. They're not close together in a line. So there's no linear strength there. And you can see as we get further away from 0, they start to form up into more linear groups. Okay. You'll notice that bottom right one looks a lot like my students' example for the field goals and the points for the NBA. And it's a 0.99. Okay. So we look at our examples. Here's this one. Look, she said it was a 0.99. That is extremely strong. It's almost perfect. We said perfect relationships are relationships where the R value is 1. Okay. So this is about as strong as you're ever going to see. Typically, with a lot of these examples, we can see here, look at our correlation of 0.16. There's pretty much no true relationship happening here. This is a very weak relationship. And it really has to do with all these points that are on the bottom of this. Okay. And so we go to this. This is much stronger. Look how this is actually a really good relationship that we see here. It makes sense. Passing attempts and yards, that should be strong. Like, the more chances you get to throw, you should rack up more yards. Okay, that's just how it works. And then yards and TDs. Well, passing yards does not necessarily mean more TDs. It looks like Tua was able to get 3 touchdowns, and he threw a lot of yards because that's Tua. I guess he had a really good game. His QBR was 87.5. That's one of the higher ones. Brock Purdy had a better game, 91.3. So, his QBR was good. But yeah, this is not as strong of a relationship. I think that's pretty obvious. Like, this one's much stronger, but we're seeing how that we're starting to get a sense of these R values. Okay. Now there will be a test question where you have to look at R values and make distinctions between what you think the values would be. Okay. The last thing that we're going to talk about is the outliers. So for outliers, when you're identifying them, we don't really have a particular method for this, but pick individual points that fall away from the overall pattern. Okay. And this will be our last note. We'll be done after this. So I think I promised a 30-minute video, but we're 38 minutes in. Let's write this down here. And then let me move this over. Okay. And then we'll talk about the assignment that you're going to have to do. So let's write this down. Actually, I do want to show how my student picked this. Her pattern was really strong, and everything was really close except for this one point here. So she said an obvious outlier is at 5.5 field goals, which I don't really know how you take half a field goal. So I'm a little confused by that. It is unusual to gain over 20 points from that many field goals. Okay. So she's just sort of talking about it in context as well, which I appreciate. But that's kind of what you're going to want to do. When you're talking, you're just identifying something. So she said this point right here is falling outside of the overall pattern. So you're just sort of picking one. Maybe there's 2 that sort of are away from the pattern. And you want to sort of explain what those are in context, because each one of these dots represents an individual player. If that's what we're talking about, it could be a team. Here, I don't think anything falls out of a pattern. Let's look here. I mean, these kind of are all in a pattern. Sometimes it's really tough, but we aren't going to talk about this line yet. I'll throw it in here, but you're looking for something. So I would say Tua is sort of an outlier if we're looking at the overall pattern. Once we get this line in here, you see it says calculate least squares regression line. If you want to just click that, you can. But you can see this line here. Tua is definitely an outlier, right? He had a phenomenal game. His yards per attempt was 10. He was way far and above. Like Derek Carr had 9.2, it looks like. But he was getting, per attempt, he was getting more yards. Okay, he was getting more yards. We can go here. Let's see if there's... I mean, this graph is just sort of strange, the way that all these plots are down here. This is not a very good graph, and that's why the relationship is so weak. So there's not even a really way to put like outliers for this one. Maybe, maybe our boy Tannehill would be an outlier. He's falling far away from the pattern, and a lot of these other ones too. So this would not be an appropriate one to analyze, in my opinion. I would never do my PowerPoint assignment over that relationship. I would move on to something else. I'd find a different relationship to analyze. Okay. So let's go ahead and talk about the assignment that you're going to have to do. So it's a pretty straightforward assignment. This will be up on Teams by the time you get to class. You're going to go find any sport you want. I don't care what it is. It can be individual players. It can be, it can also be teams if you want it to be. I don't really care. But you're going to download a file from a database. I don't really want you to use the quarterbacks data that we have. If you want to go to NFL Reference, let me show this. If you want to go to NFL Reference and you want to do any of these, if you go to seasons, here's the 2023 season and do leaders, you could do that if you want, because that's what I did. And then you could find another category to go with. Like you could do any of these other things like catches and stuff. Or I almost would prefer that you did the 2022 season and you did the leaders. We've done that before. But if you want to do NBA, soccer, I don't think that they've put up the soccer just yet. Here's football. Let's see if they've added to where you can do Spanish here. Let's see if they've made it to where you can export. It doesn't look like they have yet, so I don't know when they'll get that back up there. So you can't do really soccer or anything like that. But baseball, NBA, you could do college for either of these if you want. If you want to do hockey, you get to pick what you want to do. Right now, you're going to be able to create the Scatterplot in Statplet. Remember, most must be quantitative. Make sure that you... we're going to label our explanatory and response variables. Keep misspelling that. Okay, so label those and say what they are in context. Now, we're not ready for this part B yet. We'll go over that next week, I'm sure. But interpreting the data, we've talked about how to do all of these parts here. We have not yet done the extrapolation, interpolation. We will get to that, and we need the line of best fit to do this. Okay. Now we kind of already have the line of best fit. Like we've been able to find it. So we did that here. Here's our equation. So if you want to go ahead and include that, you can. We just need to. This needs to be explained a little bit more before you go into it, and we'll talk about what all this other stuff is too. Okay, so good luck with that. If you have questions, save those for me. On Friday, we're going to begin with our presentations over the last project that we had. But you go ahead and for the remainder of class, you're going to be working on this assignment right here.